When we open a science textbook or look at a classroom poster, we are usually presented with a neat, colorful diagram of the solar system. The sun is on the left, followed by the 8 planets lined up in a row like marbles on a shelf, separated by a few inches of colorful space. While these diagrams are helpful for learning the order of the planets, they are also a profound lie. They are fundamentally incapable of showing the truth because the truth is too big to fit on a page. The solar system is not a crowded neighborhood. It is an impossibly vast, hauntingly empty cathedral of space. If we were to draw a map to scale with the Earth the size of a pea, the map would have to be miles long. To understand the real scale of our home is to realize that we don't live in a system, so much as we live in a massive dark void where tiny specks of matter are lost in the distance. To begin our journey of scale, we must start with the sun. If the sun were a large beach ball, roughly 1 meter in diameter, the Earth would be the size of a tiny grapeseed located about 100 meters away, the length of a football field. In that 100-meter gap, there is almost nothing. You would find Mercury, a grain of sand 40 meters from the sun, and Venus, another grapeseed at 70 meters. Mars, the red planet, would be a smaller seed located 150 meters away from the sun. This is the inner neighborhood, and even here the emptiness is staggering. If you were standing on that grapeseed Earth, the sun would look like a small, bright light in the distance. Between these 4 rocky worlds is a vacuum so perfect that it makes the best vacuum chambers on Earth look crowded. We often think of space as filled with light, but light itself is a traveler through a desert. Even at the speed of light 300,000 kilometers per second, it takes over 8 minutes to cross that 100-meter gap to Earth. If the sun were to vanish right now, we wouldn't even know for nearly 9 minutes. Beyond Mars, we enter the asteroid belt. Hollywood movies like Star Wars have taught us that an asteroid belt is a chaotic shooting gallery, where pilots must dodge millions of tumbling rocks. In reality, the asteroid belt is another lesson in emptiness. There are indeed millions of asteroids, but they are spread across a region of space so vast that if you were standing on one, you likely wouldn't be able to see another one with your naked eye. The average distance between asteroids is about 600,000 miles more than twice the distance between the Earth and the Moon. If you were to fly a spacecraft through the belt without even looking at your navigation charts, the chances of hitting an asteroid are 1 in a billion. It isn't a wall of rock. It's a sparse scattering of dust in a massive lightless room. Once we cross the asteroid belt, the scale of the solar system enters a new, terrifying dimension. We reach Jupiter, the king of planets. On our scale, where the sun is a beach ball, Jupiter is the size of a grapefruit. But it isn't nearby. Jupiter would be located over half a kilometer, 0.3 miles, away from our beach ball sun. The gap between Mars and Jupiter is a wasteland. It is nearly 350 million miles of nothingness. And as we move further out, the gaps grow exponentially. Saturn, another grapefruit, would be a full kilometer away from the sun. Uranus and Neptune, the size of lemons, would be located 2 and 3 kilometers away, respectively. By the time you reach Neptune, the last planet, you are standing nearly 2 miles away from the beach ball sun. From this distance, the sun is no longer a disk. It is just a very bright star, providing almost no warmth. The light here is 900 times dimmer than on Earth. We are still in the solar system, but we have moved into a realm of permanent twilight and absolute cold. Most people think the solar system ends at Neptune, but we haven't even reached the halfway point. Beyond Neptune lies the Kuiper Belt, a dark, frozen region of icy objects and dwarf planets like Pluto. In our beach ball model, Pluto would be a tiny speck of dust located nearly 4 kilometers (2.5 miles) away from the Sun. The Kuiper Belt is a massive ring of debris, the frozen leftovers from the birth of the planets. It is here that we find the New Horizons spacecraft, which took 9 years to reach Pluto, even though it was traveling at 36,000 miles per hour fast enough to cross the United States in 4 minutes. To the spacecraft, the solar system wasn't a map. It was a decade-long journey through a void where nothing happened for years at a time. If you think Pluto is the edge, you are still thinking too small. The Sun's gravitational influence extends much, much further. Far beyond the Kuiper Belt lies the Oort Cloud, a giant spherical shell of trillions of icy comets that surrounds the entire solar system. The Oort Cloud is so far away that we measure its distance in astronomical units, the distance from the Earth to the Sun, while Pluto is about 40 astronomical units away. The inner edge of the Oort Cloud starts at 2,000 astronomical units, and its outer edge may extend as far as 100,000 astronomical units. On our scale, where the Sun is a beach ball 100 meters from Earth, the outer edge of the Oort Cloud would be over 6,000 kilometers, 4,000 miles away. That is the distance from London to New York. The solar system is not a neighborhood. It is a territory that spans a continent. It takes a comet from the Oort Cloud thousands of years to fall toward the Sun, spend a few weeks in the inner solar system, and then begin the long, lonely journey back to the dark. The best way to understand the scale of the solar system is to look at the speed of light. We are taught that light is the fastest thing in the universe, a limit that nothing can cross. In our daily lives, light is instantaneous. When you flip a switch, the room is lit. But on a cosmic scale, light is agonizingly slow. If you were to watch a real-time simulation of a photon leaving the Sun, it would take 8 minutes to reach Earth. It would take 43 minutes to reach Jupiter. It would take 4 hours to reach Neptune. If you were watching this on a screen, you would get bored. You would see a tiny dot of light crawling across a black background, making almost no progress against the vastness of the void. This is the reality of our existence. We are trapped in a system so large that even the fastest messenger in nature takes a workday just to cross it. Right now, 2 human-made objects are trying to leave this massive structure. Voyager 1 and Voyager 2, launched in 1977, have been traveling away from us for nearly 50 years. They are currently over 14 billion miles away. They have officially left the heliosphere, the bubble of charged particles created by the Sun, and entered interstellar space. But even at their incredible speeds, they haven't left the solar system. They won't reach the inner edge of the Oort Cloud for another 300 years, and they won't exit the outer edge for another 30,000 years. We have sent our fastest machines into the dark, and they are still effectively in our backyard, struggling to reach the gate. Why is it important to realize how big the solar system really is? Because it changes our perspective on the search for life and the future of humanity. When we talk about colonizing Mars, we are talking about a journey to a grain of sand 50 meters away. But when we talk about reaching the stars, we are talking about a journey that is fundamentally different in scale. If the Sun is a beach ball in London, the nearest star, Proxima Centauri, is another beach ball located in New Zealand. Between London and New Zealand, there is nothing but the vacuum of the interstellar medium. The solar system isn't just big. It is an island in an ocean of emptiness that is so large it defies the human capacity for language. There is a profound humility in understanding the real scale of the solar system. It reminds us that Earth is not a large world. It is a microscopic speck in a vast, dark room. It makes our pale blue dot seem even more fragile. Every conflict, every war, and every triumph in human history has happened on a grapeseed 100 meters away from a beach ball. The emptiness of the solar system is a shield, but it is also a challenge. It protects us from the violent events of the deep galaxy, but it also makes it incredibly difficult for us to ever leave our home. To be a spacefaring species is to be a species that has learned to navigate the nothing. It is to be a species that isn't afraid of the gaps between the marbles. As we move into the future of space exploration in 2026 and beyond, with missions like the James Webb Space Telescope and the upcoming Artemis missions, we are slowly filling in the map of our home. But we must never forget that the map is mostly empty space. The real scale of the solar system is a story of silence and distance. It is a grand cathedral where the architecture is made of gravity and the pews are billions of miles apart. The solar system is not what you see in the textbooks. It is a vast, lonely, and beautiful expanse that invites us to look up and wonder. It is a reminder that while we have mastered our own small world, we are just beginning to understand the true size of the house we live in. We are the inhabitants of a speck, dreaming of the distance. And as we continue to push our telescopes and our probes further into the dark, we are slowly realizing that the most important thing about the solar system isn't the planets themselves. It's the incredible, awesome space that holds them together.